Today we're going to start looking at Unit 11, and we're going to deal with Section 1. We're going to start talking about surface area and volume when we're dealing with rectangular prisms, triangular prisms, and pyramids. This is a rectangular prism. It has a width, a length, and a height. This over here is a triangular prism. It's a triangular prism. It has a triangle as a bottom, or sometimes a triangle as a side. And since you have to have a triangle, you got to deal just a little bit differently than the rectangular prism. On a triangle, you've got the base of the triangle, the height of the triangle. Remember, the height and base here are perpendicular. The height may or may not be a side of the triangle. This is considered to be the area of the base. And then you have the height of the prism. Height of the triangle, height of the prism. So we got formulas here for calculating all aspects that we're going to be working with. Rectangular prism, we got the surface area, 2 times the length times the height, plus 2 times the length times the width, plus 2 times the width times the height. Volume is length times width times height. Over on the triangular prism, we have the lateral area, which is just the area around, not the top and the bottom, just the area around, is the height times the perimeter. P is the perimeter of the base. Surface area is the lateral area plus 2, and this is the capital I, B, is the area of the base. Because remember, lateral area, as I mentioned, is just around the sides. So I want the surface area, I want the lateral area, the sides, and then the area at the top and the bottom. Volume is the area of the base times the height. So let's do the surface area of a rectangular prism. Width, length, height. So 2 times the length times the height, 2 times the length times the width, 2 times the width, 7. 2 times the width times the height. So we get 160 plus 112 plus 140. And when we add all of that together, we get 412. The volume, length times width times height, is just all of them times each other. So the length times the width times the height, 540. Now one thing you should note is that the surface area is whatever the measurement is squared. So if this was centimeters, this would actually be 412 centimeters squared. The volume is cubed, so this would be 540 centimeters cubed. Triangular prism. We've got the triangle here, and then the height of the prism. So surface area, the lateral area, height times the perimeter. The height is 15. Remember, that's the height of the perimeter. The height of the prism, times P, the perimeter of the triangle. 5 plus 7 plus 6. So that's 15 times 18. And so we get, for the lateral area, we get 270. Again, if I did measurements, let's say these were inches this time, this would be inches squared. So surface area is the lateral area plus 2 times B. B is the area of the base. Well, we've got a triangle here. So the area of the base is the area of a triangle. Area of a triangle is 1/2 base times height. Base of the triangle, height of the triangle. Base of the triangle, height of the triangle. So 6 times 4. 1/2, 6 times 4. That's 12. So the area of the base is 12. So I'm adding the lateral area plus 2 times the base, 2 times 12. So we got 270 plus 24, we get 294. Now the volume is big B, the area of the base, 12, times the height, and that's the height of the prism. So 12 times 15. So 12 times 15, we get 180. And again, if these were inches, surface area, inches squared, volume, inches cubed. Now, one thing we got to be aware of, when we're dealing with triangular prisms, we've got a triangle, which means we might need to do Pythagorean Theorem or trigonometry. So here, we've got 2 sides of a triangle, and we've got to find the third to figure out the perimeter. Here we're going to use Pythagorean Theorem. 6 squared plus 8 squared equals x squared. 36 plus 64 is x squared. So x is the square root of this, which is 100. Square root of 100, is 10. So we got to be aware, Pythagorean Theorem, we might have to use. Also trig, we need to be aware, we might have to use trig. So again, trig, here we've got an angle and one measurement. So I got to use trig to figure these out. So let's start with x. Opposite, hypotenuse. O and h, sine. Sine of the angle is the opposite over the adjacent, opposite over hypotenuse. X is on bottom, so we divide. 6 divided by sine 50. 6 divided by sine 50. What do we get? We get 7.8. Now, let's find y. Opposite, adjacent, OA, tangent. So tangent of the angle is the opposite over the adjacent. Y is again on the bottom. Divide. So I do 6 divided by tangent of 50. And 6 divided by tangent of 50, I get 5. So I'll need these numbers to figure out the perimeter and the area of the base. So that's why sometimes I might need to do Pythagorean Theorem or trigonometry. Now let's talk about a pyramid. A pyramid, what we're going to be working with, has square bases. So in other words, all of these sides on the base are all congruent. So we've got a couple things here. We've got the height of the pyramid, the slant height of the pyramid, the area of the base, also the perimeter of the base. So here's our formulas. The lateral area is just the sides, no base, just the area of the sides. 1/2 LP, L is the slant height, P is the perimeter. Surface area, the lateral area plus big B again is the area of the base. And volume is 1/3 area of the base times the height of the pyramid. So let's do an example. Here we go. I've got the height is 8, the slant height's 10, and look at this length is 12. So the perimeter, 12, 12, 12, 12, 12 times 4. 48. Area of the base, 12 times 12. And you may find it helpful to differentiate all of your stuff separately out. So whenever you need the P, you have it. Whenever you need the big B, you have it. Lateral area, 1/2 LP. So it's 1/2 L, slant height, times P, the perimeter of the base. So 1/2 times 10 times 48, and we get 240. Now again, if I gave these measurements, let's say these were in feet, this as an area would be feet squared. Surface area is the lateral area, 240, plus the big B, 144. So that's 384. And again, this is area, surface area, feet squared. Volume, 1/3, big B, which is 144, times the height of the pyramid, which is 8. And I get 384. This is volume, so feet cubed. Now one thing to think about here and realize this was pure coincidence that my surface area and volume were the same. Generally that will not happen. This is pure coincidence that they were the same. Now just like with the triangular prisms, we have right triangles here, which means we could be using trigonometry and Pythagorean Theorem, because we need things like the height, the slant height. We also need the base to figure out all aspects of these. So let's demonstrate that. So here we go. The height is 12. Now this 10 is referring to this whole length. So this is half of that. It's 5. 5 squared plus 12 squared equals x squared. Pythagorean Theorem, 25 plus 144 is x squared. That's 169, so the square root of 169 is x, so it's 13. So again, we need to be aware of Pythagorean Theorem we might need to use. But also, we might need to be using trig. So same idea. I'm going to call this length here x, opposite, adjacent, tangent. So the tangent of 70 is the opposite over, this belongs here. Tangent of 70 is the opposite over the adjacent. X is on bottom, divide, 10 divided by tan 70. 10 divided by tan 70, we get 3.6. I round it. To find the slant height, I'll call it y, opposite, hypotenuse, so sine. It's the opposite over the hypotenuse. Y is on the bottom, divide. 10 divided by sine of 70, which I forgot there. 10 divided by sine of 70, we get 10.6. So you need to be aware that you might need to be able to use these. That's the end of the lesson. See you next class.